Continuing with our 3.4 day 1 notes, instead of doing 8 and 9, I actually want to do A and C. So 8 and 9 will become try problems. Part A, when I first look at this, I see that there is a GCF of x, because remember, we're always looking for GCF first. If I pull out an x, I'm left with x squared minus 49. I can factor further here. X squared minus 49, that is a difference of two squares, where A is x and B is 7. So I have x times x minus 7 times x plus 7. Let's take a look at C. Once again, checking for a GCF. I do not have a GCF here. Not all three terms are divisible by the same number, and I can't pull out a variable. I cannot use guess and check because A does not equal 1, so this is an instance where you would have to use box method, if you remember me teaching you that. I'll go over it real quick. For box method, the first term goes in the first box, the last term goes in the last box, and then you need to multiply those two terms together. So 2x squared times a negative 2 is a negative 4x squared. We then list out the factors, which are 1x, 4x, 2x, and 2x. Because it's negative, I know I have to use different signs. And I want to get to a positive 3x. It's my middle term here. I can use different signs to get a positive 3x with the 1 and 4. The 4 must be positive. The 1 must be negative. I then would put those into my empty boxes. It doesn't matter if you have them flip-flopped or not. And then I'm going to switch colors here. We're going to begin pulling out the GCFs. So we want to look at each vertical pair and each horizontal pair. And we look at the outermost box for the sign, always writing our answers on the top and on the left. So looking at this first pair right here, the GCF would be a negative 1. Again, looking at the outermost box, which was negative. Looking at our next pair, 2x squared and 4x, both terms have a 2, and both terms also contain an x. It is positive because this is a positive outermost box. Looking at this pair right here, it's going to be positive because I have a positive outermost box. And then they both contain an x. Here, I have a 4x and a negative 2. It's going to be a positive because I have a positive outermost box here, and they are both divisible by 2. So my answer here is 2x minus 1, x plus 2. Please pause the video and try all of the remaining problems, and hit play when you're ready to check your work. Starting with 8 and 9. In purple, I wrote the method that I used, and green is my work and the answers. Feel free to pause the video to check your work. So here you can clearly see A through H. And then last bit, C, F, and I. Now you are ready to take a look at the new material. We are going to be factoring by grouping and also factoring the sum or difference of two cubes. When you factor by grouping, we're going to use this for polynomials with 4 terms. And it's called factoring by grouping because we're going to separate our polynomial into 2 different groups. We would put the first 2 terms together and then the second 2 terms together. Looking at each set, we then want to identify the GCF. So when I'm looking at this first pair right here, x cubed plus 3x squared, the GCF here would be x squared. And in parentheses, we would write what remains. So x plus 3. In our second set of parentheses, negative 4x and negative 12, we would have a GCF of negative 4. And in parentheses, we would write what remains, so x plus 3. Our goal is to get it so that this parenthesis matches this parenthesis, and it does. Then, technically, that x plus 3 is the new GCF of these two terms, and I can pull that out. So I'm going to put x plus 3 in parentheses out front, and then in another set of parentheses, we write what remains, the x squared minus 4. You have now factored by grouping. However, we always need to see if we can factor any further, so we need to factor this completely. The x plus 3, that cannot be factored any further. However, the x squared minus 4, this is a difference of two squares, so I could put x plus 2 and x minus 2. Take a look at number 11. Once again, factoring by grouping is when we have 4 terms, which I do here. It doesn't always work, but I'll give you problems that do for the time being. We need to pair the first 2 terms and the last 2 terms together and identify the GCF. So the first 2 terms have a GCF of x squared, and I'm left with x minus 1. The second 2 terms have a GCF of a negative 25. Now the reason why I'm pulling out that negative is because I need this parenthesis to look exactly the same as this. So this needs to be a positive x first. And in order to get a positive x, I had to pull out that negative 25. And notice how if I pull out a GCF of a negative 25, this now becomes a negative 1. This is now the new GCF, the x minus 1, and I am left with the x squared minus 25. Okay? I need to factor it completely. The x minus 1 stays the same, however, I do have a difference of 2 squares. I have now factored completely. That is my final answer. Please pause the video and try the next 2. J was pretty similar to 10 and 11, so hopefully that went off without a hitch. You would end up with x minus 2 times x squared minus 9, and you did have to factor further in order to factor it completely. However, K was a bit different. The GCF for the first 2 was an x squared, and the GCF here was a positive 4. So we're left with x plus 1, 2x plus 1 and 2x plus 1. Pulling out the 2x plus 1, we're left with the x squared plus 4. I hope you did not factor any further, because even though the x squared and the 4 are perfect squares, it is not a difference of 2 squares. So this right here is not factorable, making this our final answer. Now we're going to take a look at the second type of factoring in this section, which is the factoring of the sum or the difference of 2 cubes. All you have to do is just use the rules in the table that I gave you. Okay, we're going to have something cubed plus something cubed and plug it in. When I look at number 12, this is not x cubed, it's x to the 4th power, but the reason why is I need to always remember to check for a GCF. I can pull out a GCF of 5x here. And when I pull out a GCF of 5x, in parentheses, what remains is x cubed plus 8. This is very, very similar to how we treat the difference of 2 squares. I ask myself, what cubed would give me this, and what cubed would give me this. So what cubed would give me x cubed? Well, that's x. What cubed would give me 8? Well, that would be 2, because 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8. Because it is an addition sign, I need to use the sum of two cubes. Which says that it's going to look like this. A plus b in the first parenthesis, so x plus 2 times a squared. So a squared would be x squared minus a times b. X times 2 is 2x plus b squared. 2 squared is 4. Let's try another one. Number 13. Okay, I need to ask myself, what cubed would give me 8y cubed? Well, 2 cubed would give me the 8. Y cubed would give me the y cubed. B would be whatever cubed would give me 27. So let's say I wanted to try 3. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Hey, that works. So B is 3. Because I'm subtracting, I know I need to use the difference of two cubes rule. Here's the difference of two cubes rule. In the first parentheses, I have a minus b, so 2y minus 3. And in the second parentheses, I have a squared, so 2y squared. Be careful with this one, because both the 2 and the y need to be squared. So this is a 4y squared. Plus a times b, so 2y times 3, that would be a 6y. Plus b squared, so 3 squared is just 9. Go ahead and pause the video and try L and M. Number 1 was a challenge problem, or excuse me, letter L was a challenge problem, if you didn't notice. That one was a little bit more tricky because A was 2, that one was easy, but B would have been Z squared, because Z squared being cubed would give me Z to the 6th power. When we have a power to a power like this, we multiply. This is an Algebra 1 rule that you may or may not have forgotten, and we're going to see that later in the school year as well. Because of the addition sign, I knew it was a sum of two cubes. So I would use the rule that was in the table up here, which is a plus b, and then a squared, a times b, b squared. And the signs were plus, minus, plus. For m, you had to pull out a GCF first, which was 2x squared. Then it was a pretty straightforward difference of two cubes, and the signs are minus, plus, plus when we have a difference of two cubes. I hope you noticed while trying these problems that the sum and the difference of two cubes are the exact same except for the signs. So when you're adding, so when you have a sum of two cubes, it's plus, minus, plus. When you're subtracting, so a difference of two cubes, it's minus, plus, plus. But both of them are a and b in the first parentheses, and then a squared, ab, and b squared in the second set of parentheses. So again, the only difference is the signs.